Hey guys, welcome back. Today we're analyzing data. So what I have here next to me are the absorbance measurements from the scanner and what I learned from them. If you recall from my last two videos, I've been studying whether or not patients who have had COVID-19 have antibodies to other coronaviruses they could not likely have come into contact with. On this page next to me, I have the readings from plate 1, which has patient antibodies bound to a coronavirus. The numbers above the graph tell us how much antibody is present in each well from the plate. Some of the patients have had COVID-19 and recovered, the numbers in bold and italics, while some of the patients have not had it, the numbers only in bold. What I have learned from the experiment on this plate is that there is no significant difference between the average amount of antibody of positive patients and negative patients to the virus on the plate. Now let's move on to the next plate, plate 2. This one's a little more complicated because there are 3 different coronaviruses on the plate. Recovered patients are still in bold and italics, and negative patients are still in only bold. In columns 2, 3, and 4, there is one coronavirus, which we'll call D. In columns 5, 6, and 7 is another coronavirus, which we'll call B. In columns 8, 9, 10, and 11 is another one, which we'll call C. The positive samples in the D section had 27% more antibody to D than the negative samples in the D section. There was no significant difference in antibody between the positive and negative samples in the B section, but the positive samples in section C had 10% more antibody to C than the negative samples in section C. What we can learn from this is that people who have recovered from COVID-19 have antibodies which recognize more antigens on coronaviruses C and D than patients who have never had it. This information could be very useful when searching for a COVID-19 vaccine candidate. Thanks guys for watching, and please subscribe.